Hello everybody, this is the third and the last video on the chapter sets. I've already made the first two videos, first part 1 for the students of class 6, part 2 for the students of class 7 and now part 3 for the students of class 8. However, for a complete idea about the chapter, one can view all the 3 videos that are already uploaded in the YouTube. We come across certain terms while doing the chapter sets. Let's discuss those. First, finite set, infinite set, singleton set, joint set, disjoint set, equal set and equivalent set. Now, finite set are all those sets whose elements can be counted. Now, if I say set of vowels in English alphabet, now this is finite. Why? Because we know there are A, E, I, O and U. So there are fixed number of elements in it. Now if I say infinite and then if I say counting numbers, set of counting numbers, now this is infinite. Why is it infinite? Because the elements in it starting from 1 will just go on and does not have a fixed number of elements. It has uncountable number of elements in it. Singleton set is a set which has only one element in it. For example, if I say set of all even prime numbers. Now if you know, there is only one even number which is prime. And what is that? 2. All other even numbers are composite. So in that case, this is a singleton set. Now joint set, in fact these are pair of sets. Let's say if I am taking 2 sets, A, vowels of English alphabet, and B are all the alphabets present in English till Z. Now the elements of A are present inside B. There are some common elements of A and B, and in fact there are A, E, I, O, U and U. So they are called joint set. But this joint set would be if A is vowels and B are the first 5 counting numbers. Now they are disjoint set because you don't see any common elements in the two. So in joint set there are common elements. In disjoint sets there are no common elements. Now equal and equivalent. Now they are two different type of sets. So in equal sets, if the two sets talk about the same elements in different ways, let's say first 5 counting numbers. Which are the first 5 counting numbers? We know they are 1, 2, 3, 4 and 5. So let that be set B. So the elements of set A indirectly 1, 2, 3, 4, 5. Element of set B 1, 2, 3, 4, 5. Exactly same elements. They are called equal sets. Now for equivalent set, the elements need not necessarily be same. Let's say this is A, E, I, O and U, and set B is 1, 2, 3, 4 and 5. These are different elements. But if you look at the number of elements present in A, this is the cardinal number, is 5, and number of elements present in B is also 5. Therefore, they are equivalent set. So in equal sets, the elements are same. In equivalent set, the number of elements are same. Now in class 8, we come across questions like this. Just see here, set A is equal to set of single digit counting numbers. Set B is equal to set of multiples of 3 less than 20. And universal set sets the boundary for the maximum number of elements for that particular question. So the universal set is the set of whole numbers up to 20. So if I have to write these sets in roster form for greater clarity, then set A would be 1, 2, 3, 4, 5, 6, 7, 8, 9 because these are counting numbers and single digit. So counting number starts from 1 and I can't write 10 because it is not a single digit number. Now set B is equal to set up multiples of 3 less than 20. So 3, 6, 9 in the table of 3, this is what you get, less than 20. So I can't take 21 after 18. And universal set all the whole numbers. So I am starting from 0 up to 20. So I have to write up to 20. Now in class 8 you are usually asked to express such sets in Venn diagram. So let me just show you how to present this in Venn diagram. If I just consider this box to be the universal set, means all the elements of this question should be present inside this box. Now from that, this is for set A and this is for set B. So first thing we will do is take the common elements which are present both in set A and B. So just see here, 3 present in both, 6 present in both and 9 present in both. So that is to be listed over here, which is intersection 3, 6 and 9. Then the remaining elements of A should be written here and the remaining elements of B should be written over here. So which means it would be 1, 2, 4, 5, 7, 8 are the remaining elements of A, 12, 15 and 18 are the remaining elements of B. Now if you look at this, I have already written everything that belongs to A over here and everything that belongs to B is over here. 3, 6 and 9 is written only once because it is repeating in both. Now the remaining leftover elements of the universal set will be present outside. So let me write the remaining ones, that is 10, 11, 13, 14, 16, 17, 19 and 20. Now the question is asking us to express A union B, A minus B, A's complement, A intersection B, B minus A and B's complement. Now this can be represented in the form of Venn diagram. So I have expressed all the statements in Venn diagram. Now when I say A union B, from here if you see A union B, and I need to take this area, this is A union B, that is A and B all together. So in this area I have these elements, so that is A union B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 15, 18. That is what is listed out over here. When I say A intersection B, I am supposed to take the elements which are present in this area. So just see here, the elements which are present over here, 3, 6 and 9 written over here. When I say A minus B, from A all the elements of B to be removed, so I have to look at the elements that are present in this place. That is 1, 2, 4, 5, 7, 8 is what I am writing over here. Now when I say B minus A, from B I am removing the elements of A. So this is the place that I am supposed to focus on. So the elements which are over here, that is 12, 15 and 18 are taken over here. When I say A's complement, means leaving the elements of A and leaving all the elements which are present in this area. So all the remaining part are to be taken. So that is here 12, 15, 18 and then 10, 11, 13, 14, 16, 17, 19, 20. That is what is written over here. Now when I say B's complement, leaving the elements of B. So all the numbers that are written in the outside zone and this part here 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19 and 20 are the elements. Now let us write the cardinal number. So when I write the cardinal number, how many elements, number of elements in A union B, A union B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 would be the number over here. In intersection 1, 2, 3. In A minus B 1, 2, 3, 4, 5, 6. And B minus A 1, 2, 3. A's complement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And B's complement 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Now we were asked to prove that number of elements in A plus number of elements in B minus number of elements in A intersection B is equal to number of elements in A union B. So let's see number of elements in A. Number of elements in A that we have, number of elements in A we have is 1, 2, 3, 4, 5, 6, 7, 8, 9 plus number of elements in B 1, 2, 3, 4, 5, 6 minus number of elements in A intersection B 1, 2, 3 here. That should be equal to number of elements in A union B all together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see. 9 plus 6, 15. 15 minus 3 is 12. 12 equals to 12. That is true. So these are the type of questions you will find in your book, ML Agarwal or any other book that you are referring. So you are supposed to look into the concept, re-look into the example sums that are given in your book. It may be difficult to understand everything with the help of a single sum. However, I have tried to sum up everything that usually comes in different sums. Have a look at the various example sums, take clue from them, and then look into the video, and then please do the sums that are given in the exercise in your book, in your class 8 book. So all the very best. Thank you.